In this video, we're going to briefly discuss matrix multiplication. So matrix multiplication involves, as the name suggests, multiplying two matrices together. So you'll notice the ones I have here, this is a one row, two columns, so it's a 1 by 2 matrix. This one has two rows, one column, so it's a 2 by 1 matrix. Now, in the resulting matrix, the first row and the first column get multiplied together. In this case, there's only one row and only one column. And what happens is, sorry, this should be a 1 up here. So I take the first row and the first column, and that's going to form the first row, first column entry in this new matrix. So in this new matrix, the way we multiply matrices is we take this and treat it as if it were a tower collapsing on top of this matrix here. So if you were to kind of imagine this thing falling over, the 3 would fall on top of the 4, and the 6 would fall on top of the 2. If you kind of lifted it up a little bit, it's easier to see. Well, what happens is the number that it lands on get multiplied together, so 4 times 3 and 2 times 6. Well, there are two numbers there. What do you do with them? Well, by human definition, what we do is we multiply the numbers that land on top of each other, and we add those things together. So in this case, we would get 12 plus 12, which is 24. And so our answer would be 24. The resulting matrix would be, notice, 1 by 1. Okay, let's suppose that we take a bigger matrix. We take a 2 by 2, which I will just say 4, 1, 3, 6, and then this matrix here will be 2 and 4. So what we do here is same idea. Now what I'm going to do, actually for visual purposes, I'm going to lift this up for you, 4, 1, 3, 6, and I'll put the 2, 4 up here. So in this case, you can kind of see that the 2, 4 collapses. Well, it's going to be taken with the first row and the first column. That will be our first result. Okay, so in our product matrix, what we're going to have is the first row is going to collapse on top of the first. The first column is going to collapse on top of the first row, and it's going to form the first row, first column entry in our new matrix. So the 4 will crash on top of the 2, the 4 will crash on top of the 1. We'll have 4 times 2 plus 1 times 4. Well, what do towers do when they fall? Unfortunately, bad example. The tower collapses all the way down, right? So it's going to hit this first row, but then it's also going to come down and crash on top of the second row here. So that means we're going to take the second row by the first column. That's going to create the second row, first column. So the 2 would land on top of the 3. 3, so we get 3 times 2. The 4 would land on top of the 6, so we get 6 times 4. Now in this case, we're going to go ahead and add them. So we get a matrix which is going to be 2 rows by 1 column, and then there's going to be 8 plus 4, which is 12, 6 plus 24, which is 30, and there's our final product. Now, the same type of property applies regardless of what size. If I added another row, then I'd have a third row in my product matrix. What happens if this matrix becomes bigger? Well, if that matrix becomes bigger, and say we have 1, 2, 3, 4, and 0, 5, 1, 2, or 0, 4, 1, 2, in this case, we still treat it the same way. Well, every row has to hit, every column of this matrix has to hit every row of this matrix. So if I take the first row, first column, might be again easier to elevate this thing a little bit. The 0 will land on top of the 1. This will be first row, first column. The 1 will land on top of the 2, add them together. 0, now we're on the second row, still first column, so you get 0 times 3 plus 1 times 4. So the 0, 1 carry down both rows. Well, I've done that with the first column for both rows. Now I'm going to do it with the second column for both rows of the first matrix. So now I'm going to be in column 2 of my product. That means that the 4 is going to crash on top of the 1, the 2 is going to crash on top of the 2, and I get 4 times 1 plus 2 times 2. Collapses down on top of the second row, so I get 4 times 3 plus 2 times 4. Again, notice that the 4 and the 2 are common here and here. 0 and 1 are common here and here. So that means my product will be 2. This will be 4. 4 times 1 plus 2 times 2 is 8. And 12 plus 8 is 20. And there's my final matrix, which you notice is a 2 by 2. So let's make a general result here. If this is a 2 by 2, and this is a 2 by 2, the inner dimensions matched, meaning that the number of columns of the first matrix match the number of rows in the second matrix. So